All right, here we go. It's time to do some horizontal shifts on quadratics. So we've done previously vertical stretches, compressions. We're multiplying by a number bigger than 1 to stretch it, and by a number between 0 and 1 to compress it. We've looked at adding numbers to the x squared value to raise it up, shift it up, and subtract numbers from it to shift it down. Now we're looking for what to do to the equation to make it look like that. We'll do one. Okay, so investigate what that would be like. And notice, of course, you see here a key point here of 0, 0 as translated to become 4, 0. Okay, so the x is changed by, it's moved over 4 steps anyways, right? So you're going to hopefully give this a try and see if you can figure it out. Let's delete some stuff here. So we've got, there's the x squared, and what do you need to type in, right? And so the hint that I have on the page here is I don't want you to think about, I don't want you to try and do an equation where you have all of the numbers, like when you have ax squared. There you go. I don't want you to think of all the numbers, ax squared, the b, a, b, and c. It's just one number only. Okay, so it's not all that stuff. You're not, you're just basically working on this fundamentally, and you're going to have a number somewhere that'll make it look like that. This one's definitely trickier. I would encourage you to play around with it, try and figure it out. I think I said in other videos, or videos of my in-person class, that when you're looking at changing the equation, you only really have 4 options, right? Add, subtract, multiply, and divide. Trick being, of course, when you think, okay, well, if I subtracted 4 or added 4, that's actually moving things up and down, right? So that's not going to work. We already know what that one does. So you're going to try, come back, look for some more hints, So if you're coming back and looking for more hints, my hint would be that you need to basically add, or you need to change the value of x directly, right? Of x directly. So you need to change the value of x directly. So if you're guessing like x plus 4, right? That's x directly. Outside of that, there's this concept of the thing has to be squared, right? So that's what works or ends up leading to this. So I'll show you here. I'll put in that guess of the x plus 4 squared, and I'll just show you what it does. And then we'll talk about y too a little bit, but x plus 4, and then it's all squared, so power of 2. So it looks kind of like what we're looking for, but it went the wrong way. Okay, so I'm just going to take a screenshot of that. We have a record of having seen that. I'll just go to a new page here, and I'll make a note that moves it the wrong way. Okay, so that's actually a plus sign. It didn't show up great, so I'll add it in better here. So if it's x plus 4, it goes the wrong way. Well, if adding makes it go to the left, what would you do to make it go to the right? It goes the wrong way. So basically, logic dictates here, right? If adding makes it go to the left, then logic would dictate probably that subtracting makes it go to the right. So let's try it. We'll do another page for that one in a bit, but let's change this to subtract. Right there. Subtract. And hit enter, and boom, it goes the right way. Okay? So that's success in the end here. We're like, okay, I see what I need to do. Hopefully you find it a little bit surprising. It's kind of weird. If you don't find it surprising, either you already knew it or you just are missing what I'm trying to show you here. So this negative in here, right, actually moves it to the right, which I think is kind of odd, right? So how you think about that? How you should think about that is, you could even do for the 0 point, right? So we have this point where 0 goes in and you get 0. So y equals x squared. You get 0 gives 0, right? The question is, what equation would you have so that you're putting in a 0 and getting an answer of positive 4? So you got an x, y equals something, and you're putting in a 0 and you're getting a 4, right? Well, you think about, if I put it into x, take away, well, if I put in x plus 4, it'd become plus 4 would be 8, 8 squared would not be 0. But if I put it into an x minus 4 equation, then when I put in a 4 in here, it becomes 4 take away 4, which is 0 squared, right? And so it gives you 0 squared, which is 0, which was what we needed. They sometimes use confusing wording in textbooks where they say, what do they say? So basically think of x squared, right? And then they say, okay, you want this thing to be a value. I can't even word it the way they do. They come up with being a value so that it will be what it used to be or something. It's really confusing. And I've kind of deleted it from my vocabulary because it's just not a great way of talking about it. But yeah, this x minus 4 squared, if you think of, I'll just leave it at that. I think I've done a good enough job. Let me know if you need any more questions or help with that. But I don't want to worry you too much about it, but basically just need to know that it's backwards. And I actually have a saying to do with that, where see how I've written as like negative plus? So in other words, I often describe it as brackets backwards. And I'm encouraging you to just know that. And so if you're looking at an example of, y equals x plus 2 squared, then you know that it went to the left, right? So this went to the left 2, because it's backwards. It's positive. You'd think it would be to the right, but instead it goes to the left. Okay, so we've seen that it's true. We've seen sort of like why it's true as well. So if this is negative, it shifts to the right, which is kind of odd. And if it's positive, it shifts to the left. Yeah, it's odd, but that's okay, right? So the trick to remember the backwards result, this might be a bit redundant from, so this might be a bit redundant here, but brackets backwards, like I said, right? And so the why is it backwards? Well, like I showed on the other page, right? So this is actually the wording for the textbook. So I do have it there still, but it's not my main focus. So what does x need to be now to make the quadratic be 0, right? So for this one here, what does x need to be now to make the result be what it used to be? In other words, it used to be 0, and so now it needs to be a 4 to be 0, right? So that's the idea of the wording that sometimes is used in textbooks, okay? So what does that look like in our examples when we do this? So I'm going to show you that, remember I talked about, I don't know if you remember or not, but I talked about how I should have just put the x's in. Immediately what came to mind when I was saying that was like, except in the case where you're moving it horizontally, because we actually do that. We actually change the value of the x. So let's do the graph version first, because it'll be really easy. And then we'll make the table make sense based on the graph and see what we need to do. So there's your regular y equals x squared. And if I'm trying to do this graph, I know, because I know about brackets backwards and so on, I know that it's going to go to the left 2, right? So it's going to be 2 to the left. So we're like, okay, let's do that. Let's go to the left. Everything goes to the left, right? So there's a point there, there's a point there, 2 to the left, there's a point there, and so on. 2 to the left, point here, 2 to the left, there's a point there. Okay, so once you have all those dots and you look at it, it's like pretty obvious that you have your shape here. So you're like, okay, that's my y equals x plus 2 squared. Okay, so that's my equation. Like overlap like that. So y equals x plus 2 squared. Okay, so when we're looking at the table of values, we're saying, okay, well, where's it at a 4 now, right? Then one of the answers is 0, and one of the answers is like negative 1, 2, 3, 4, right? So what we're doing is we're saying this one was like 0 and negative 4, so it's the end ones that I just talked about. Let me just do this to show you what I mean. Just to focus on the ones, right? So we know those are the spots, right? Well, what you want to think of is this x value got changed to be a negative 4 instead of a negative 2. So it's actually subtracting 2 from the x's. Okay, so we're subtracting 2 from the x's. And that's, I'm pretty sure, if I remember right, I put in here, right? Yeah, the x value point gets 2 subtracted from it. It's just what we see on the graph, right? It's to the left, so we're subtracting by 2. So again, subtract 2 from a 1, you get a minus, from the x, 2 from negative 1, right? So I'm going to have to be careful with that. I was illustrating the common mistake that people would do, of course. Take away 2, and you get negative 3. And then take away 2 from the 0, you get negative 2. Take away 2 from the 1, you get negative 1. And take away 2 from the 2, you get 0. Okay, so you're doing that. Take away 2 from the x's each time, getting your new x's. And that's different from our other two cases. The other two cases, we're getting new y values. This one, we're keeping those y values, but getting new x values. Okay, so that's the graph and table of values version of the horizontal shifts. Okay, I should also point out, I suppose, that the textbook version of this, so I go up to this page here, I guess, but I kind of want to just show you how textbooks show it. So let me add this in here. Many textbooks. So people that write textbooks tend to be very mathematically minded, of course, right? So they sometimes communicate things thinking that everybody's that way. And I don't think it's true, right? So they'll often show just y equals, like I did on the other page, really, but the x minus the number here, A, K, P, and Q, whatever letter. I think down this text or this resource I had, they used, what did I use for this one? An H. So we'll use an H. Okay. So they say, take away the H squared and so on. And they want you to think of it as, if H equals plus 3, for example, meaning you want it, like you're intending to the right. Ending a shift to the right. Now, I'm not recommending you think about it this way, but I'm just trying to prepare you for things you might see. So if you're intending that to be to the right, well, then this equation works because you put the 3 into there, and the equation becomes y equals x, take away that positive 3, right? Take away that 3. And so when you graph that, it does indeed move it to the right. But it's such a robotic way of thinking about it. I'd much rather you be very conscious looking at this thing saying, okay, I know it's going to be backwards, and so it's to the right. Rather than relying on saying, oh, in this case, what do you even say? Like x minus h equals x minus 3. And so you end up solving and saying, oh, so x's cancel out or subtract from both sides, and you have negative h equals negative 3. Therefore, h equals positive 3. It's just not intuitive. It's just not a nice way to go about it. And I'm a mathy person, so there you go. Yeah. So that one we already did. This one here, let's do this one. So again, you look at this example and you say, okay, a negative 1 in there. Okay, so I know that each spot's going to get moved to and you have to force yourself to be careful here. You mean negative, and so it's to the right, right? So it's to the right 1. And you just graph it and show it. Let's do the table first this time. If we're going to the right 1, we're going to be adding 1 to all the x values, right? So we're going to have the x's with an add of 1 to it. So we're going to add 1 to a negative 2 and get negative 1, right? We're going to keep going and add 1, add 1, add 1 all the way along. And we're going to get a 0 and a 1 and a 2 and a 3. Right? So really, that's your graph, right? So if we're doing it by a table of values first, there's the original graph that I'm encouraging you to get good at just graphing without much thought needed. And then when you graph this thing, you're like, okay, well, my new one's at -1 and 4. So -1, 4, and 0, 1, and 1, 0, and 2, 1, go up 1, over 3, up 4. Right? So you get this new graph, and you say, okay, great, looks great, right? That's what it's supposed to be. And then you think, oh, yeah, look at it. It's moved over 1, isn't it, everywhere? We could have graphed this by just moving each of the points of the green one over 1. Instead, we did it by the table of values. Okay? So that's the two ways of going about it. You should be able to do it either way. That's definitely the goal. All right? So that one there, the blank one first for you. So the generic, of course, the idea here, you have, this idea of this sign here. The textbook will just put as a minus, but I'm encouraging you to think of it as brackets backwards, right? So to the right if it's negative, and to the left if it's positive. It's brackets backwards. I started saying it that way a long time ago, and just kind of like two B's, so it's kind of catchy, whatever, brackets backwards. Seemed to work, and a lot of the teachers in this school at least say it that way a lot too. Now, anyway, so there's not much to do here. This is, of course, the H's added, right, and so on. So if it was a negative case, you're adding to the H's, the X's, and if you're positive case, you're subtracting. Okay, so I won't do that as much. I could, I suppose, show the original quadratic, quick here, and then point out, the idea that we're shifting all the points to the right if we had something like x minus a number, right, and all the points the other way, right, if we had x plus a number. I'm happy with that. I hope that makes sense. All right, so the next press here, let's well, this is the same idea as before, where you would, if you're doing more than one transformation, so you'd want to start with the original. So x and y, this is where it equals x squared, of course, and we have our -2, -1, 0, 1, 2, and squaring it gives us 4, 1, 0, 1, 4. And you graph it. Y equals x squared, graph. And then if we're going to try and do each piece as we go, we can either do this vertical stretch compression transformation that's going on first, and then shift it all. Obviously, here, this is to the right, based on what we just did. It's to the right 3 underlines, because it's, be careful with that one. This one is flipping it, right? That's a vertical stretch, but it's not changing size. It's just flipping upside down. So let's just flip it upside down. That's easy to do. Unless you botch one of the points. Oh, I'm doing too much on me. Oh my gosh. I'll get it right. Close enough, I guess. Not my day. And so that's the y equals wrong color. The y equals the -x squared as a first step. And then, of course, we can just shift it over, right? So let's just shift it over to the right 3. So 3 steps for you, 3 steps for you, and so on. This is a little awkward when you have like 2 side by side, but you can kind of slightly stagger them so they Anyways, and then in the end, you go and you put your dots on all the spots, and it becomes obvious what you're drawing, of course, right? Because you got it all there. All right. For some reason, that one went better for me. So this is the combined total of a negative and an x minus a 3 squared. Okay, so if we did the flipped version first, we have x and y equals negative x squared. And of course, that would just be the same x's. And the values would just be minuses now. So a -4, a -1, a 0, and a -1, and a -4. Okay, so that's where your y's got multiplied by a negative. And so right there, this y value got multiplied by a negative. Easy. Down the column there, all do the same, and then the blue one in the end. So we got x and we have y equals the negative x minus 3 squared. We're going to have the same y values this time as the new one, right? So the new one's going to be those same y values. So we're going to have the -4, -1, 0, -1, -4. So just like in the original, we flipped, got the red one, and then we shifted the red one. Now we're using the red one information for the y's, and we're just going to shift the x values. And you can tell the x values on the graph are clearly all moved over to the right 3 steps, right? So we're going to move this one over 3 steps. So it's going to be at 3. So there's the 3, 0 that's on the graph and on the table of values. So add 3, add 3, add 3, 1, no, 2. Right? 2 and add 3 is 1. Okay, so you can see those spots all there. We have the 1, -4 right here, and so on. And the 2, -1 there, and so on. Okay? Get rid of those because we don't need the green dots, but just wanted to show you. Yeah. So hopefully that works for you. The summary of this stuff we already kind of did, but obviously here we have if h is greater than 0, this is the textbook version of things. I kind of want to not show this at all. So if h is greater than 0, then they're going to say, oh, that goes to the right, but it's only because we've got this robotic equation here for this robotic interpretation, right? Instead, you do the backwards brackets backwards idea instead, really, right? I'm hoping that works for you because it's much, much easier to think about. Okay. Yeah. So, for example, here, the equation for this one would have been a y equals an x plus a number squared for that one. And this one would have been a y equals an x minus a number all squared. Okay. So hopefully that works for you. Don't hesitate to post questions and ask for help if needed. All right. See you later.